Hello everyone, my name is Vedad, I'm the developer of Mimea, and today I will be demonstrating the software and the technology behind our project. As you may notice, behind me is not the exact product you have seen in the presentation video. Instead here we have just a plain old TV screen. The reason behind this will be clearly shown throughout the video, so please hang on. One of the technologies mentioned in the presentation video is exactly the facial recognition technology, which unfortunately, due to the time limits, hasn't been demonstrated. So I'm going to be using some sort of introduction to the video as a means of testing the facial recognition technology. So everything the user needs to do is look in front of the camera. The camera in the presentation video is actually attached to the middle of the product, but right now I have took the hardware apart. In my hand I am holding a Raspberry Pi 3B Plus with a 13 megapixel camera attached. So as I previously said, everything the user needs to do is just look in the lens, in the eye of the camera, and facial recognition will do its job. So what do we have here? My personalized profile has been loaded, and this is the exact same settings that have been shown in our presentation video. So the loading screen, the smiley face that has been searching for you has disappeared, which, as I just said, we kind of use as a loading screen because we didn't want the mirror to look just like a plain old mirror. So there's a keyword, mirror. This obviously here is not a mirror, it's a TV screen. The reason why I'm presenting the technology on a TV screen is because I'm going to use this chance to just demonstrate how every other smart mirrors actually work. So, as stated, here we have a TV display attached to a Raspberry Pi, which is running Raspbian OS, a Linux OS, with the Mimea software installed. Everything the manufacturer needs to do is just add this reflective film, I guess. It just needs to be attached to the surface of the display. Immediately it's getting its reflective properties, and because it's used as a window film, it has to be see-through on one end and well reflective on the other. Why do we decide for this approach? There are many features of Mimea that make our product distinct, that make it different from a sea of different smart mirrors. One of its aspects is the price range. So, as I said, we have a display screen. The cheapest screen you can get is probably around $30–40. We're talking about a standard HD screen. We are running Raspberry Pi 3B Plus, and recently it was on sale due to its anniversary, and you can get it for $35. Camera module around $15–20, and the film foil. The film foil that we use to cover our mirrors costs around just $5, and those $5 can cover approximately around 3 to 4 mirrors. So let's round up all those numbers. Let's say the whole product costs $100. It is much more cheaper than any other home alternative you can find. But a smart mirror aimed at helping older people that are suffering from dementia does not exist. Sure, there are personal mirrors that you could hack to somewhat get the same result, but at the end of the day, you'll have to do obviously a lot of work, a lot of programming, and you'd pay a lot more. But one thing I have to focus here is our Azure database implementation. Sure, the user statistics are saved on our database, how much they use the mirror, where the mirror is located, is connected to the weather, the user's religion and country of origin is connected to calendar, and so on and so on. But our key feature is therapy. The mirror itself eventually kind of loses its point without the implementation of therapy. For example, this part here. As mentioned in the previous video, the therapy section can be controlled via Google Tasks, which is this one here, or via the Azure database that we created. So the patient can at any time while accessing to the mirror can see what kind of medications they need to take, why they need to take them, have they took them, how often do they need to take them, and those said medications can be altered and changed by remote control or directly controlling the database. All of this is quite intuitive and easy to control and can be done by literally any caregiver that just has a smartphone. I don't want to demonstrate again the remote control. It has been demonstrated nicely in the presentation video, and I don't want to lose any more of our precious time. So yeah, the therapies, medications can be controlled if you're a caregiver via a special code you get for every patient. Say hello in Japanese.
In Japanese, that's こんにちは.
Jarvis. Play Miles Davis on Spotify. So as has been shown currently, you can use voice assistant to do an array of different things, such as asking repetitive questions. For example, what day today is, what time is, eventually asking repetitive questions such as this tends to act somewhat as a memory exercise. And again, you can use it even to start maybe learning a new language, which in itself is a memory exercise. You can also use the voice assistant to play music. That also study shows that Alzheimer and other usually mental illnesses, mental patients tend to enjoy music on a much higher level than your average person. So if the user can play music whenever they want, whenever they feel like to, again, that might help them relieve their anxiety or depression. Also, one study shows, we have documented that in our documentation, that a vast majority of elderly people who are in a retirement home do unfortunately have, or at least show, symptoms of depression. And again, music seems to be a temporary solution, at least to fix their day. And if it does make their day happier, or even if it makes the minute of their life happier, I think we have done a good job. Once again, my name is Vedad. Thanks for sticking throughout the whole video. And this is my meal.